Hi everyone, myself Ramapogla Mallikarjuna. I am working as assistant professor in Mlritm. So today we discussed about set theory and that relations and their properties. Relations and their properties. What is the relation? Relation is the collection of ordered pairs known as a relation. So it can be denoted by symbol capital R. Symbol capital R. In that order pair, first element is from first set and the second element is from second set. For example, x equals 2 comma 3 comma 4 and y equals 3 comma 4 comma 5 comma 6 comma 7 comma 8. These are the two sets and given condition is x divides y. Find the relation R. So x divides y means x divides y. So relation R equals to, we can write 2 comma 4, 2 comma 6 and 2 comma 8, 3 comma 3, 3 comma 6 and 4 comma 4, 4 comma 8. This is the relation. So 4 is divisible by 2 and 6 is divisible by 2 and 8 is divisible by 2. 3 is divisible by 3, 6 is divisible by 3, 4 is divisible by 4, 8 is divisible by 4. This is the relation given two sets. This is the relation. What is the relation? Collection of order pairs as known as a relation. Here first element is from first set, 2 is first set and 4 is second set. So second pair is 2 is from first set and 6 is from second set. So here 2 is from first set and 8 is from second set and so on. This is the example of relation. And next topic is types of binary properties. Types of binary properties. So we have 6 types of binary properties. First one is reflexive property and irreflexive property, symmetric property, asymmetric property, transitive property. Last one is anti-symmetric property. Then what is the reflexive property? What is the reflexive property? A relation R is on set A set to B. Reflexive property, it is satisfying A comma A belongs to R. If A belongs to A, here R is the relation and capital A is the set A. Capital A is the set A. What is the condition for reflexive property? A relation R is on set A set to B. Reflexive property, it is satisfying A comma A belongs to R. If A belongs to A belongs to A. So for example, A equals, in that condition, A comma A, in this pair, A is from first set and second A is from second set. Here a set A equals to 1 comma 2 comma 3 and relation R equals to 1 comma 1, 2 comma 2, 3 comma 3. Here first element is from, in this pair, first set and second element 1 is from second set. So A comma A and second pair is 2 comma 2. So here A, first element is A and second element is also A, and here the third pair 3 is first set and this second 3 is second set. So it is satisfying condition A comma A belongs to R. So A comma A belongs to R for all A belongs to A belongs to A. This is the reflexive property. So one more example for this. Here for example, relation R equals to 1 comma 1, 1 comma 2, 3 comma 2, 4 comma 2, 2 comma 2, 3 comma 3 and 4 comma 4. And a equals to a set a equals to 1 comma 2 comma 3 comma 4, 1 comma 2 comma 3 comma 4. So given relation 1 comma 1, 1 comma 2, 3 comma 2, 4 comma 2, 2 comma 2, 3 comma 3, 4 comma 4. So it is reflexive property or not. Given relation reflexive property or not. So here relation contains 1 comma 1 and 2 comma 2 and 3 comma 3, 4 comma 4. So it is satisfying reflexive property. Here a comma a belongs to R. So that means 1 comma 1 belongs to R, 2 comma 2 belongs to R, 3 comma 3 belongs to R, 4 comma 4 belongs to R. So it's satisfying reflexive property. It is satisfying reflexive property. So and second property, irreflexive property. Irreflexive property. Here a relation R is on set A set to B. Irreflexive property, it is satisfying a comma a does not belongs to R. A comma a does not belongs to R. So here in pair 1 comma 2, for example 1 comma 2, R equals to 1 comma 2 and 2 comma 3. Here first element is from first set. Given relation first element is first set and second element is from second set. Here second pair 2 is from first set and 3 is from second set. Here what is the condition in reflexive property? A comma a does not belongs to R. A comma a does not belongs to R. Here given pair is first pair is 1 comma 2. So here a comma a does not belongs to R. And second pair is 2 comma 3 does not belongs to R, and that means a comma a does not belongs to R. So it is satisfying irreflexive property. It is satisfying irreflexive property. Here what is the condition? A comma a does not belongs to R. And one more example for this irreflexive property. R equals to 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4. So given relation is irreflexive property or not. Irreflexive property or not. So here given relation R equals to 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, given 1 comma 1. So these elements are same. So that means a comma a belongs to R. A comma a belongs to R. A comma a belongs to R. So it is not satisfying irreflexive property. It is not satisfying irreflexive property. And here 2 comma 2. So both elements are same. So it is satisfying a comma a belongs to R. So it is not satisfying irreflexive property. Irreflexive property. And same 3 comma 3, 4 comma 4 does not satisfying irreflexive property. Irreflexive property. So this is the about reflexive property. And symmetric property. In this symmetric property, a relation R is on set A set to B, set A set to B, a reflexive set. A relation R is on set A set to B, symmetric property, it is satisfying A comma B belongs to R and B comma A belongs to R for all A comma B belongs to A. Here what is the condition? A comma B belongs to R and B comma A belongs to R for all A comma B belongs to A. So for example, set A equals to 1 comma 2 comma 3 and relation R equals to 1 comma 1 2 comma 1 3 comma 2 2 comma 3 4 comma 2 4 comma 3 4 comma 4. So given relation is satisfying symmetric property or not. So here given pairs are 1 comma 1 2 comma 1 3 comma 2 2 comma 3 4 comma 2 4 comma 3 4 comma 4. So first pair is 1 comma 1 and we have to check the here first element is from first set and second element is from second set. So next pair is starting B element. So here there is no starting B element, so it is not there. So next pair is 2 comma 1 and it is 2 is from first set, that is A, and 1 is from second set, that is B, and we have to choose the next pair is starting B element. So 1 comma 1 B comma A B comma A. So A comma B means 2 comma A 2 comma A. So here 1 comma 2 comma 1 does not 2 comma 1 belongs to R, 1 comma 2 does not belongs to R, and here 3 comma 2 belongs to R and 2 comma 3 belongs to R. So 3 comma 2 belongs to R, 2 comma 3 belongs to R, satisfying the symmetric property, and 4 comma 2 2 comma 4 does not belongs to R and 4 comma 3 is belongs to R, then 3 comma 4 does not belongs to R. So here only satisfying the one pair, 3 comma 2 belongs to R and 2 comma 3 belongs to R. It is satisfying symmetric property. And one more example is, I will give one more example for symmetric property. A set A equals to 1 comma 2 comma 3 and relation R equals to 1 comma 2 2 comma 1 1 comma 3 3 comma 1 2 comma 3 3 comma 2 and this is the relation. So here 1 comma 2 belongs to R, then 2 comma 1 belongs to R, and one more is 1 comma 3 belongs to R and 3 comma 1 belongs to R, and 2 comma 3 belongs to R, 3 comma 2 belongs to R. So it is satisfying the symmetric property. This is the example for symmetric property. And asymmetric property, a relation R is on set A set to B. Asymmetric property, it is satisfying A comma B belongs to R and B comma A does not belongs to R. This is the condition for asymmetric property. So for example, a set A equals to 1 comma 2 comma 3 and relation R equals to 1 comma 2 3 comma 2 2 comma 3 and 1 comma 3 3 comma 1. This is the relation. So here 1 comma 2 is belongs to R. So 1 comma 2 is belongs to R and 2 comma 1 does not belongs to R. So it is satisfying the asymmetric property. And second pair is 3 comma 2 belongs to R, then 2 comma 3 also belongs to R. So this pair is not satisfying the asymmetric property. And 1 comma 3 is belongs to R. 1 comma 3 is belongs to R, and 3 comma 1 also belongs to R. So it is not asymmetric property. So given relation is it is not asymmetric property. This is the asymmetric property. And antisymmetric property. Fifth property is antisymmetric property. Here a relation R is on set A set to B. Antisymmetric property, it is satisfying two conditions. First one is A comma B belongs to R and B comma A belongs to R. If and only if A equals to B, that means 1 comma 1. So it is and 2 comma 2, 3 comma 3. So it is satisfying 1 comma 1, 2 comma 2, 3 comma 3. That means A equals to B means two elements are same in pair. And second condition is A comma B belongs to R and B comma A does not belongs to R. If and only if A is not equals to B. If and only if A is not equals to B. For example, 1 comma 2 relation R equals to 1 comma 2, 2 comma 3 and 3 comma 1. This is the one example for relation. So here 1 comma 2 is belongs to R and 2 comma 3 belongs to R and 3 comma 1 belongs to R. So here 2 comma 1 does not belongs to R and here 3 comma 2 does not belongs to R and 1 comma 3 does not belongs to R. So it is also satisfying the antisymmetric property. So this is the about antisymmetric property. So one more example for this one. A relation R equals to 1 comma 2, 3 comma 2, 4 comma 1, 4 comma 3, 2 comma 3, 3 comma 3 and 1 comma 3. So set A equals to 1 comma 2 comma 3 comma 4. So given relation is satisfying antisymmetric property or not. So here pairs are 1 comma 2, 3 comma 2, 4 comma 1, 4 comma 3, 2 comma 3, 1 comma 3. So here in this antisymmetric property we have two conditions. First one is A comma B belongs to R and B comma A belongs to R. If and only if A equals to B. And second condition is A comma B belongs to R and B comma A does not belongs to R. If and only if A is not equals to B. Here observe that given relation 1 comma 2, 3 comma 2, 4 comma 1, 4 comma 3, 2 comma 3, 1 comma 3. So here clearly we know that A is not equals to B. So it is satisfying the second condition. A comma B belongs to R, B comma A belongs to R, B comma A does not belongs to R. That is A is not equals to B. So 1 comma 2 belongs to R, 2 comma 1 does not belongs to R and 3 comma 2 belongs to R and 2 comma 3 does not belongs to R and 4 comma 1 belongs to R and 1 comma 4 does not belongs to R and 4 comma 3 belongs to R, 3 comma 4 does not belongs to R and 3 comma 1 comma 3 belongs to R, 3 comma 1 does not belongs to R. So it is satisfying the antisymmetric property. So last property is transitive property. A relation R is and set A set to B transitive property. It is satisfying A comma B belongs to R and B comma C belongs to R, and then A comma C belongs to R for all A comma B comma C belongs to R. That is means A comma B comma C belongs to A. So set A equals to A comma B comma C. So here for example a relation R equals to 1 comma 2 and 2 comma 3 1 comma 3, set A equals to 1 comma 2 comma 3. Here 1 comma 2, so first pair I will take, first pair is 1 comma 2 1 comma 2 and 1 comma 2. So in this pair first element is A and 2 is B, and again we can take the starting from B element, so 2 comma 3, so 2 is B and 3 is C. So then A comma C, what is the element? What is the pair? A comma C. So 1 comma 3 belongs to R, 1 comma 3 belongs to R. So it is satisfying the transitive property. It is satisfying the transitive property. So this is the all about binary operations, binary properties. Thank you.